Hey everybody, let's talk about California water. So it's interesting if you look at a map of the US, you can see that this is showing the amount of precipitation across the country. You can see that on the east side of the US, we have a lot of precipitation. Except if you hit about the 100th meridian, which is the 100th latitude line, people noticed even when the colonizers were coming to the US, before they called it the US, they notice that there's a certain point where suddenly the water stops. It stops raining so much. There's just not a lot of water available. Okay, so the Mississippi is the biggest river in the US because there's so much rain available on this side. It drives that river to be so huge. But then all of a sudden it gets really dry in the West until you hit the Pacific Northwest and the upper part of California. So what is even going on here? Why does this matter? Well, it matters because we can't grow crops if there's no water, right? We can't have cows if there's no water. We can't have any, it's hard to be alive if there's not a lot of water, if you're not evolved to live with that. But humans like to live everywhere. And so we have found ways to live everywhere, including in especially Southern California, where there's very little water. Okay, so what is happening? How does California deal with this? Let's talk about it. We've actually noticed that in the past 50 years or so, this line of dryness has actually started moving east because of climate change. Okay, so first of all, you may ask, well, why is it wetter on the East Coast? And it's because the Appalachian mountain range is so old. It's like one of the oldest mountain ranges on the planet, that it's been ground down through erosion for so long that it's kind of a very short mountain range. There are caves in this region that have never seen life because they are so old. Okay, so they've been ground down through erosion and plate tectonics for so long that they allow all the nice moist water from the Atlantic to travel over the mountain range and get further and further, further and further into the atmosphere above the east side of the US, and then that can come down as rain. On the West Coast, that's not how our wind currents work. Our wind currents are trying to take away the water at the 30th parallel, as we know, the 30th latitude line, which is right where LA is. So that makes us very dry. And the Rocky Mountains are so big that they actually block a lot of the rain that could move east from moving in. Okay, so you'll see this nice delineation right here, this nice marker basically. That's where there's a bunch of mountains that block the rain from going into the other parts of the country. Okay, so this is, remember, that's called the rain shadow effect, where you'll have one side of the mountains that have a lot of water and another side that doesn't, just because the mountains block that water. Cool. So let's talk about California. What's happening in California? You'll notice that, let's go here. So we have what's called a water budget in California, determined by what are called the hydrological regions. And so we know how much water we get about each year. We know how much has to be used for plants, so that they end through evaporation based on how dry things are. And that tells us that we have a certain amount of water available that can be run off into rivers and lakes, which is our main source of water in California. We then can take that and we say, okay, some of that goes to the ocean, and then some of it we store in what are called reservoirs, and that's how we store our water in California. We have water available in the groundwater in what are called aquifers, but we don't use it very much because we don't need to. We have these reservoirs that we built. Okay, so you may live near a reservoir. So let's look this up real quick. LA reservoirs. Whoop. Okay, so there's a Silver Lake Reservoir, the Chatsworth Reservoir, the Ivanhoe Reservoir. A lot of these places, because they're just areas where water is stored, they're very nice, happy, ecological regions. I used to really like going to the Hollywood Reservoir to just exercise, because it's just a pretty place to just walk around. There's a very cool dam here. We'll talk about why that's important. And it's just cool. And there's lots of animals. There's lots of plants. There's lots of animals. It's nice and cool here because it's next to the water. And it's not very busy because not a lot of people know about it. So it's a nice, chill place to just do some exercising. But importantly, it's also a nice place where we store a lot of water for when we need it. Okay, so this isn't a place where you can go and swim because they're trying to reduce the amount of contamination and increase the amount of ecological service that this place can do. Okay. Cool. Was it that? Okay, cool. So in those reservoirs, some of it is used for, most of it, the reservoirs we have are used for agriculture. And then some of it's is reserved specifically for urban purposes. And then the rest is allowed to go to ecological purposes. Okay. Cool. What does that mean? What's happening? So most of the rain in California actually falls in the top third of the state, and it's all because it's part of that. It has to do with the way the wind currents move. So up here, the wind is bringing water in from the ocean, but then once you start hitting down here, the wind is moving water away from the continent and over the oceans. It's stealing our water. Okay, just like Nestle. So what does that mean? Okay, so if you look at this cool picture, it shows you where water is coming from in different parts of California. You'll see if you count, there are 10 hydrological regions. That's what these each say. We've basically taken the state and divided it into 10 areas based on where the water comes from. Okay, so where is water coming from that people are using or could use? You'll see that, okay, groundwater or surface water is, so surface water specifically, not groundwater, and that's rivers and lakes. You'll see that's the biggest chunk. So rivers and lakes give us most of our water, okay? We then have, some places don't have a lot of rivers and lakes, and so they draw from aquifers or groundwater, okay? So that's what the purple is. And then others have to recycle their water. Okay, so you'll notice places like the Bay Area, they have to recycle a bunch of their water. The Central Coast has to recycle a lot of water because they don't have a lot of rivers. There is the Salinas River that comes down through here, but most of that is used for agriculture. So they don't use that as much for urban use, okay? And LA has to recycle a lot of its water just because there's so many people. And if we just let all of it go off to the ocean, it would destroy the ocean. And also people wouldn't have enough water to use for everything else. Okay, so good to know. Moving on. So let's talk real quick about what an aquifer is. It's just aquifer is literally, or groundwater is literally any water underground. Easy peasy. Some places they have to draw from their groundwater. They dig wells and then they draw it up. In LA or just California in general, we can get water from enough of the state that we haven't had to make a lot of wells. But this is where that idea with Nestle coming in and stealing our water is a big issue. So what they have done, so let's say this is California and Nestle's in another state like Nevada, they drill wells that then go into California's groundwater and they pull that water out. And you might think, who cares, Miss Knoll? Who cares? We care, because if you draw that water out, it's like making a sponge really dry and then brittle, and then the land on top of it collapses, which is why we see so many sinkholes in California. Okay, a sinkhole is an area where just the land collapses above something because it's no longer stable. And so you start seeing areas where, oops, the land collapsed because there's not enough water underneath to support the soil anymore. So it could be on a house. It could be in a road. And so we're very concerned to make sure that we actually maintain our groundwater levels so this does not happen. Okay. It's also why when you're going to dig really big holes, they make you, can you imagine? Look at this. They make you like you have to get a lot of permits so that you make sure you aren't drilling into an area that then is going to become a sinkhole. Okay. Can you imagine? That is an entire car in a sinkhole. Holy cow. Okay, cool. So that's that. We're going to talk about why it's not great. We could fill this with salt water, but then the plants are drinking salt water and that actually kills them. And that's not good. Cool. We'll talk about it. Let's talk first about, so we talked about where the water comes from. What is it used for? So the yellow is telling us it's used for environmental reasons. The pinkish red, whatever this is, the maroon, I guess, hello, maroon and gold, is used for agricultural reasons. And then the bluish purple is urban reasons. So you'll notice Northern California, they get so much water that they can just let the environment take most of it. Okay, we start going a little further south. That decreases a bit. It decreases a lot. And then you'll notice that the agriculture part goes up a lot in what's called the Central Valley. This is called the salad bowl of the world because we can grow so many amazing, just beautiful crops in this region. That's why avocados are cheap in California, because we can grow them here very easily. Same with oranges, grapes, all these different things, because of the Central Valley, because these mountains, as rivers run over them and they erode, they provide such good nutrients for this area that they then can grow such amazing crops. But you'll notice, where's my map? This map, so this is the Central Valley here. There's no water there. So we have this beautiful area that's perfect for growing crops, but there's no water. So how do we get that water there? we move it in using the aqueduct. Okay, so there's a California aqueduct that runs from Sacramento all the way, or from Stockton and Sacramento all the way down to LA and San Diego, so that we can pull water all to different areas that need it, because these areas don't get a lot of water. And so if we drew just from these lakes, they would be gone immediately. And so we have to pull water from where there's a lot of water to where there's no water. Okay, you'll notice that in there we go. In all these places, it's pretty well balanced, environmental and agriculture. Oh, a lot of agriculture. And then boom, Southern California has the highest use of water for urban reasons. Okay, so that's drinking water. That's there's some crops here. There is the like recreation. There's a big recreation, like pools and stuff. But the biggest problem, so this is what it looks like when agriculture uses water. So the way we plant agriculture right now, it looks like this, and we spray a lot of water. We lose a lot of water through evaporation. But as we move back to other older forms of farming that are more efficient, that make more sense, we retain a lot more water. The biggest problem with the LA region and other regions of the U.S. in general is that lawns use a lot of water. It's not agriculture that wastes the most water. It is actually lawns that waste the most water. So imagine seeing a lawn like this, and we all know lawns like this, where you see this beautiful lawn and you're not allowed to touch it. Why? Why even have a lawn if it's beautiful and you're not allowed to touch it? I don't understand. If you have this lawn, you should be able to play sports on it, walk your dog on it, whatever. But there are people who are like, no, don't touch it. It's my lawn. And lawns actually started in before the French Revolution, when people were like, I have so much land, I don't even need to have a farm. And so it's kind of a holdover from that, where we're like, we must have this land, we must make it pretty, but we don't need to grow any crops on it, so because we're so fancy. Okay, and so the problem is this grass that people like to put on their lawns is not native to California. It's not native to the U.S. at all. And it takes a lot of fertilizer and water to keep it alive, which is very counterintuitive, because you take out the native grasses, which are evolved to live here, and you put in this one kind of grass that everybody likes to use for their lawn called Kentucky blue stem, and then you have to baby it to make sure it doesn't die. Oh, so a lot of people realize that takes so much water, it makes the water bill insane. So they started doing what's called xeriscaping, which I can never spell right, which is where you make the area look like what it should look like natively. Because so LA, if you go out into the wild parts of LA, it looks more like this. If you look, or maybe like this, okay? And so if you make it look more native, and you use, in this area, if you use a lot of succulents, then you actually don't have to use a lot of water on it, because literally the plants are evolved to live there. You're actually, by doing this, not only are you saving money on your water bills, but you are actually promoting ecosystem health. Okay, so that's a good thing to think about if you ever get a lawn in your life. Okay, so also, if you have a lawn and you aren't like playing on it, or like have dogs and stuff, why not plant a garden? Even if you don't end up eating everything that's in the garden, at least like you're promoting ecosystem health. Okay. This to me looks a lot better than this. This looks very boring. Blech. This looks very interesting. I want to go on. I want to see what all the plants are. Look at all the pathways. It's so pretty. Look, there's flowers. Oh, so pretty. Okay. You can also do things that are ecosystem friendly with your pools. Okay, so this pool is amazing. Oh my goodness. And there are companies that set this kind of thing up, where they set up the filter, and then they set up the plants that are also helping filter. And then suddenly you don't ever have to clean it, because the plants do all the cleaning for you. And again, you save money, and you do ecosystem health, and you still have your recreation space. Also, can you imagine if this was your diving board? Oh my goodness, amazing. Okay. Where are we? Okay, so yeah, so the biggest use, Southern California's biggest use of water is for urban reasons. We don't grow a lot of crops in this part of California, though the majority of water coming to Southern California is used for crops, because like, look at this, that's so much more than this. So if you think about why do we use so much water for urban stuff in Southern California than like the Bay Area, it's literally because we have more space for lawns, and because there's just more people down here. Okay, so there are a lot of people in the San Francisco area and in the Bay Area in general, but there's still way more people in the LA plus San Diego region. Okay, so that's why so much of it is going to urban use here. Cool. So you may say, Miss Noel, Israel does desalinization. Why don't we do that? Which there's a big old ocean right next to LA. Why don't we just take the salt water and use it? Well, we're not evolved to deal with ingesting that much salt. It would kill us. Our kidneys are these little, they're pretty tough, but if you overtax them, they will break down and then you'll die or have to go on dialysis. That's a problem. So if you're on a high keto diet, kind of keep that in mind because you're shoving a bunch of proteins through your kidneys a lot, and that actually can start to damage them. So have a balanced diet. Places like Israel, where Israel is twice the size of LA County with the same number of people, and it's its own country, right? So they could do desalinization because they don't have any other sources of salt water and their population isn't super big. But if you think about like LA is it's a city in a state in a country, so they have to deal with many, many more people, so they can't just do desalinization because number one, it takes a lot of room. Okay, we don't have this much room in the country to have this many plants, desalinization plants, because people like to live on the coast, and so we can't tell them you got to leave so we can put in a saltwater treatment plant. Okay, that's no good. Also, they use so much electricity and they don't make a lot of fresh water. You can only get about 45% of the water that you take in to become fresh water before it's no longer usable. And then what do you do with that extra really, really salty water? You can't just put it back in the ocean. It's too salty and it'll kill everything. Okay. Even if it ends up even if people are like, the ocean's so big, who cares? But we would just dump it like this and then this region would die. And then that would spread out and kill more things. And that would spread out and kill more things. So some people store their salt brines underground, but then again, that can seep into your groundwater and kill things that way. Oh, it's highly problematic. Speaking of salt seeping into the ground, have you ever heard of like when marauding armies would go and they would pillage a village and then they would salt the earth? That means they would put a bunch of salt over their croplands or farmlands so that then nothing could ever grow again. So we've been doing that in human history because we're jerks for a long time. But now we're starting to see it happen naturally because of climate change, where as sea levels rise, the salt water is getting closer and closer and like pushing into the land. It starts to take over our aquifers. And then as the aquifers become more full of salt water, the plants above them are going to die. And that is a big old problem we need to worry about. Okay. What else do I want to talk about? I want to talk about turbines. So another nice thing about using a reservoir to hold our water is that we can then use them to also create electricity. Okay, so this is a turbine. So how does electricity work? Electricity works because you have something that causes this turbine to move, and that turbine moving, it's like when you rub your hands together, you get friction, you can feel that heat. Instead of heat, you get electricity. It's basically static electricity we then convert into usable current electricity that we can then use to power everything, including this recording, right? So what do we use to power these turbines that make the electricity? So traditionally, we take fossil fuels, we burn the fossil fuels so that they heat a bunch of water, and then the steam from that water moves the turbines. That's so many steps, okay? You got to get the fossil fuels, you got to burn the fossil fuels, which we know is problematic. It puts so much carbon dioxide into the atmosphere. And then you have to heat up water, which then moves the turbines. That's at least 4 giant steps. What if we take out the fossil fuel part, we take out the water part, and we just have wind turbines? Absolutely. Another thing we can do is we can do dams. So if we have those reservoirs, if they release water in a certain way, that water can then turn the turbines itself, and then that you don't have to heat it up, you don't have to burn fossil fuels, but you do get electricity. So it's a nice, beautiful way to get electricity without burning fossil fuels. I mean, this is burning fossil fuels to make the lights, but that's it. Okay, so this is a nice way that a lot of places can store water and then also use that water to make electricity. Beautiful, y'all. Do I have any more points? You're going to do an assignment based on this. If we go to my JIG, it's your second to last assignment for the year. Let's go to assignments. All right, so California's water. And so you're just going to answer these questions based on what I just told you. Okay, so let's make sure I told you everything. Pew, pew. Yes. Oh, right. So this one, remember, mountains can control where water goes. Wind currents and moisture from the ocean controls where water goes and precipitates. Salinity does not. Okay, it doesn't matter how salty the water is, you'll still get some evaporation. And right now, because of droughts and climate change, over 50% of our water is considered impaired and at risk of, not being usable. So this is definitely something that people are worried about, because if 50% of our water becomes unusable, 50% of our population is going to die at least. So that's highly problematic. We want to make sure people stay alive, and people need water. Okay, that's all I want to say. Oops. That's all I want to say. Good luck with this, and let me know if you have questions. Bye.